Okay, so we're going to do these practice problems now. I'm going to start by drawing a little picture. All right, there's my beautiful picture. Okay, so it says a rock's thrown downward from the cliff at 50 meters per second. The rock hits the waves below after 2.45 seconds. So let's draw a little rock that he's throwing down there. And VI is going to be equal to 15 meters per second. The time, let's put that over here maybe, time is going to be equal to 2.45 seconds. And our velocity being thrown downward, and this is important, I should write this here now too while I'm thinking about it, VI is going to be equal to negative 15 meters per second. All right, don't forget the negative because it's going down. Okay, that, and then also A, our acceleration, is going to be equal to negative 9.81 meters per second. And we are looking for our distance, how high our cliff is. All right, so the only thing that we are not even interested in, that didn't even come up, is VF, right? So if we look at our formula sheet, all right, so the one that doesn't even have VF is going to be this one, right? Right there. All right, so we're going to say D is equal to VIT plus 1/2 AT squared. And we're just looking for the distance, right? So we're just going to plug in the numbers. So we're going to say D is equal to negative 15 meters per second times a time of 2.45 seconds plus 1/2 times negative 9.81 meters per second squared times a time of 2.45 seconds squared. And I get D is equal to negative 66.2. It's a little bit off, I guess. 66.2 is what I got. Meters. And my answer is negative because it's comparing it to where I started. So it's 66.2 meters down, right? So you could also say that the cliff was 66.2 meters high. Okay, B says, what was the velocity after 2 seconds? Okay, so for part B, it's going to be the same info, actually, and we can't use this D anymore because the distance at 2 seconds won't be 66.2. It's going to be something else. So for part B, we're going to, we have acceleration, time, and VI, and now we're looking for VF, though. We're looking for how fast it's going at that point. So in that case, we don't even care about distance. So distance is the one that doesn't come up. So I look at my formula and say, okay, which one of these doesn't even have distance in it? Well, all of our new ones do. They all start with, they have distance, right? All 4 of those. But that one we were dealing with a while ago, that acceleration is equal to VF minus VI, or change in velocity over t, that's the one we need. So going back, so we'll go acceleration is equal to VF minus VI over t. We can rearrange this. I can say A times T is equal to VF minus VI, and then AT plus VI is equal to VF. And then just plug in our numbers. So we got negative 9.81 meters per, meters per second squared times a time of 2 seconds is our new time, plus our initial velocity was negative 15 meters per second is equal to VF. So then if you put that into your calculator, you get negative 34.6 meters per second. So that also means 34.6 meters per second down, which is what my answer is here. Okay, so that's number 1. Number 2 says a rock is thrown upward with a speed of 20 meters per second from a 45 meter cliff. How long will it take for the rock to reach the bottom of the cliff? So this one's actually really similar to the ones we went over up top here. Nope. Okay, so I'm going to kind of draw what I know here. So we know that VI is going to be 20 meters per second. And it's going up, right? So positive 20 meters per second. And our cliff, so it's going to be D is equal to, now this is a place everyone makes a mistake, it's going to be negative 45. Negative 45 meters. Because it's down from us, right? Is where what we're interested in. How long will it take for the rock to reach the bottom of the cliff? So we don't. The problem is if we use our formula from up here, right? We gotta solve for t, like with a t squared and a t, and you need the quadratic equation for that. So we can't really do that one. The other thing I guess I didn't write down that we also know the same thing we always know. A is equal to negative 9.81 meters per second squared. And we're looking for t. Okay. We're going to change it up a little bit. And I'm just going to, instead of doing that, I am going to find VF. And the reason for that is if I find VF, then we don't have to use that certain formula. So let's just say that this is it. So we're looking for VF. So if we're doing that, we'd say, okay, which formula doesn't even have T in it? That's going to be this one. So VF, that one right there. So I'm going to say VF squared is equal to VI squared plus 2AD. So VF is equal to, I know it's going to be negative because it's going down. I know it's going to be going down. So I'm just going to write the negative symbol there. So it's going to be negative square root of VI squared plus 2AD. So VF is equal to, I'll put my numbers in here, 20 meters per second squared plus 2 times negative 9.81 meters per second squared times negative 45 meters. So VF is going to be equal to, so it's going to be negative 35.818. I'll leave it. Remember, I'm just leaving this kind of long too because this isn't my final answer. So I'm leaving the decimals kind of long, so that meters per second. Now, in part 2, we can figure out, so maybe I'll write part 1 up here. Part 1. So now part 2, I'm going to use a different formula. Now, we have a bit of options here, which formula we want to use too, because now we know VF, so we know that one now too. So if I go to my formula sheet though, I kind of look through here and I say, okay, what I don't want is those, like, this one has a t and a t squared in it. That's the same problem I had before, right? So I don't really want that when I'm solving for t. But I could use this one, A is equal to VF minus VI over t, and I could also use this one. This one doesn't have t in it, so that won't work. But so what I'm going to do then is, I don't know, any, mini, money, mo, I'll use the first one. A is equal to VF minus VI over t. VF minus VI over t, yeah. And if I rearrange for that, I end up with t is equal to, VF was the number I just found, which was negative 35.818 meters per second. I'll put that in brackets to make sure I know that that's VF. Minus the initial velocity was positive 20 meters per second. All divided by, now acceleration's on the bottom. I didn't show that step of the rearranging. Negative 9.81 meters per second squared. And I get a final answer of t is equal to 5.7 seconds. So I'm going to end that video there. Just a couple things to remember. Remember about your distance being negative when you're going down, your acceleration being negative. Remember that we have a hard time solving for the quadratic one. Like pretty much this is like the case that it becomes hard, right? If you're solving for t in that case, that'll always be like the tougher one. Yeah, that's pretty much it. Just 2 parts instead of 1. So that's it for that video, and I'll see you guys in the next one.